Okay, this is another video in the series of explaining what maps are doing. So once you've found maps, you can then at least get your head around what they're doing. I've got them more or less in order, and so the last one was IQ being limited by math flow. People often call that the smoke map. So what I've done is I've moved to the turbocharger map, and that's because in the last video with the smoke map I mentioned how as the revs rise the turbocharger is kicking in, and that's giving us more air to allow us to inject more fuel. So it makes sense really to jump forward to the turbocharger map. Now it's trying to open in 3D, but it's not there, so I'll click that to optimize it. Again, it's got some highlights on it that I don't want, so I'll press delete. Turbocharger maps, when they're fairly simple basic maps, often have this characteristic shape with very often with a little flat bit and then this bump. So they're very often very easy to spot. Now what we've got, as in many files, if we've got engine speed, or so many maps, we've got engine speed and we've got injection quantity. And again, I'm more or less going to ignore the engine speed because it's by now you should be getting your head around the idea that engine speed is relatively meaningless with these maps, in the sense that you won't have any engine speed if you don't have any injected quantity. So the injected quantity rising gives us an engine speed that rises. So we can really talk about the map in terms of injected quantity, because we know that as long as we talk about this one rising, that one's going to be rising anyway, because it'd be very hard for us to get anything else as a result of injecting more fuel than an increase in engine speed. If we don't get an increase in engine speed, what we get is tons and tons of black smoke pouring out the back. So okay, if we assume there's nothing wrong, we're going to increase the injected quantity. Now what we need to know, of course, is that because this is a turbocharged vehicle and it's not a supercharged vehicle, it's using an exhaust gas turbocharger. What we need to know is we need to tie these together in our mind, don't we? Because what happens is we inject more fuel. That gives us more revs on the engine. When we get more revs on the engine, we're going to get more exhaust gas and more pressure from that exhaust gas. And when we get that, that will spin the turbocharger faster. And the turbocharger spinning faster will give us more air, which means we can now burn more fuel. And that now means we can raise the amount of fuel we injected. Getting it? And if we raise the fuel that we're injecting, the revs will rise, so the engine is going faster, the exhaust gas speed and pressure are higher, turbocharger is going faster, we're getting more air pressure, we can inject more fuel again. And so it just goes round and round and round and round. Now can you see what's going to happen if something goes wrong and you can't stop injecting fuel? If you can't stop injecting fuel, every time a little bit more goes in, the engine speed goes up, the revs go up and up and up, the pressure through the turbo, or as a result of the turbo, goes up, and all that will happen now is the turbocharger will attempt to spin faster and faster and faster and faster. Now, a good condition turbocharger on one of these cars can happily, well not happily, but it will spin at 200,000 revs per minute. So if something goes wrong in your engine and the engine leaks oil which gets sucked through into the inlet manifold and you start burning fuel and oil, the oil will burn as extra fuel and the turbocharger will run at absolute maximum or more. And if you don't get the engine turned off pretty quick, there is going to be an almighty bang. Because the whole system will just go faster and faster and faster and faster, and in the end the turbocharger will break, and in a quite spectacular manner. That's one of the reasons why the designers have done all of this, because obviously they don't want the average car to have injected fuel quantity run out of control, because they don't want the turbocharger to run out of control. I mean, obviously they're taking lots of factors into account here. They don't want you to wreck the engine, they don't want you to break the clutch, they don't want you to break the gearbox, they don't want to ruin the environment, they don't want you to have an accident by touching the accelerator pedal, getting ridiculous amounts of boost and crashing into the car in front. So there's lots of things been taken into account. But the obvious ones are don't damage the vehicle, as in the engine and its components, and don't damage the environment. And the manufacturers really don't have any choice in that. So those are the sorts of things that are being taken into account. Right, here we go then. Let's have a quick look at what's going on then. Now, again, because it's a little bit more difficult to see what's happening with the numbers when I look at the shape, I'm going to go to the text view and actually look at the numbers so that we can see what's going on. And again, I'm not going to worry too much about what's happening over here, because the pattern will be similar whatever rev range I'm in, apart from either the extreme high or the extreme low. Because at the extreme low end I'll have virtually no boost, so I'm not going to worry too much about the low end. And at the very, very top end, with a little bit of luck, something will start to limit things. So in other words, they'll have changed the map slightly to stop things getting out of control. So what I can really expect is values that are fairly self-limiting, but they've been limited on the map down at the bottom here, and values that are limiting at the top, that have been limited by the designers, and then variable values in the middle to allow for the sort of performance I might want when I'm driving. Okay, so I'll pick somewhere in the middle. I'll highlight it so that with luck we can see what we're talking about. By luck, I've not quite picked the highest. Let's go for the next one, because that's got the highest value on it. Right, get rid of that. What's that? 2350. We'll pick that one. Okay, here we go. So let's have a look and see what we've got. Now, when the turbocharger is full on song, I can expect to get, thanks to the design of it, somewhere in the region of twice atmospheric pressure. And atmospheric pressure, as we know, is somewhere around about 1,000 millibars. So down here I've got somewhere around about 1,000 millibars. So down here I'm not really using the turbocharger. There's a fair chance I'm not. Or maybe I am using the turbocharger, but I'm not injecting any fuel, or virtually no fuel. So it's a sort of a situation that doesn't really occur in real life. And that's hardly surprising, because if I look at the revs, it's 3,500 revs, and I'm hardly likely at 3,500 revs to want to inject no fuel and have the turbocharger do no work. But of course it's being taken into account because you might have just lifted your foot off the accelerator. So all circumstances are being taken into account. So what I'll do is we'll pick something where it sort of begins to make a little bit more sense anyway. Let's have a look here. We've got 10 milligrams being injected. The turbocharger is giving us something like 1.3 bar, or 1320 millibar. So more than atmospheric pressure, obviously. So it's beginning to boost a little bit there. And then if I go to 15, I've got 1425. And if I go to 20, I've got 1525. So you can see these are gradually increasing. So I've got my foot on the accelerator, and the more I press down, the more the ECU will start to give me more fuel into the injectors. And at the same time, the revs will be rising, and as the revs are rising, then I will get more boost. So they're all tied into each other. I'm getting more boost, and the boost is rising and rising and rising. But if we look here, we hit 2350, 2,350 millibars, and we've stopped. We're not going any higher. And if we look at that from the view of, I'll just get rid of that, and we look at it from the view of the rev range changing, we can see that in the middle here we've got 2350 there. The figures would be the same further down, but they're not. And if you've been listening to this carefully, you know why not. They're not the same here, because at lower revs the turbocharger hasn't managed to produce 2350. So down here we've got lower values, but only because we haven't got enough revs to get the values that we'd like. Now, of course, designers could do something about that, and one of the things they sometimes do is add an additional turbocharger or a little electric charger or a supercharger to go with it. But we're looking at simple stuff here. So basically, this has got to build up with revs rising, whether we like it or not. So okay, here we are. We've got not maximum revs, but you might as well consider this maximum revs. So you might as well say to yourself, okay, when you're driving your car, do I ever need to rev over 3,990 revs? Well, the answer to that is probably no. Because at 3,750 I've got maximum boost and maximum fueling, and from then onwards it actually goes down. So if I rev more, or I try to rev more, and I try to inject more fuel, I'm actually not gaining very much. So in fact, if I say to myself 4,000 revs is the limit for me to rev to, I probably won't be far off. And in fact, if I say to myself peak performance is somewhere around about, look at that, 2,499, and I've got 2,350. So in fact, from 2,500 revs to 3,500 revs, I'm pretty much, that's it. So for the majority of drivers driving this engine in normal conditions around every day in and out, if they just drive and use that rev range of somewhere in the region of 2,500 to 4,000, and maybe not even that far, they will get pretty much the maximum performance they need from this engine. So the car is going to run as good as it really needs to. I mean, they're going to have fine performance, fine acceleration. It's going to drive fast on the motorway. Pretty much everything they need, they've got. So they don't need to try to press the pedal down and get 5,000 revs, because there is no point. So getting 5,000 revs is actually worse than a lower rev, because they will get less fuel and they will get less turbo boost. Now, don't confuse these values with what people sometimes talk about when they talk about turbo and turbo boost. These are the boost values rising, fair enough. But because of the way the turbocharger works on this engine, it's a variable nozzle turbo, or VNT. Because of the way that works, it doesn't simply just get faster and faster and pump out more and more and more and more. It does get faster and pump out more, but not in the manner that you might expect. That's because there is not the standard wastegate system, because the standard wastegate system would open a wastegate and dump the extra pressure that you didn't want. What this turbocharger will do is change the angle of the vanes to produce less turbo effort as it spins up faster and faster. So there will be less available push from the turbocharger, but the turbocharging values will carry on rising. They just won't be rising as steeply. So it's important to bear that in mind, particularly if you look at the N75 map later, which I might well do. Right, I'm going to close that one down. Hopefully that's given you a bit of a guide. There's the N75 valve. I won't go straight to that. I'll probably make my next video the limiter, but maybe we'll end up at that at some point. So I'll stop there.